Believe you are a professional in simple eigenvalues finding. Alright, so if you want to practice more to prevent any careless mistake, I recommend you to go to this. What you can search for, it's 3 times 3 eigenvalue calculator. The first thing is this great website. So what I can do is to just sub in my values but rather than the values that is given A. Okay, so I'm just trying to prove that this is the correct answer for my lambda. Okay, and then from there then we can continue on the rest. Once I fill in my matrix, alright, I could get my, this is the form, alright, and then I could get my results. Okay, lambda 321, which is the same as what we are doing, and then the corresponding vectors. And in this video, we're going to talk about how to find the eigenvectors. Alright, so we're gonna solve for eigenvectors. To solve for eigenvectors, I'll just solve for this one, just for simplicity. Okay, so since we already know that the given, not given, we already know all the eigenvalues, we can just sub it in into our this one. Alright, if you still remember this Holy equation, please remember. And then if you do out the math, you eventually get this matrix over here. Alright, so this is a very key concept. This is the first step, I would say lah. Okay, so once you get this, but generally after that, after your finding your eigenvalues, normally they'll ask you to find eigenvectors, so you can just plug in what you have done earlier. So this is what I'm do. So what I'm gonna do next is just simply sub in what I need for. So for example, if I want to solve for lambda is equals to 1, I'll just sub in lambda is equals to 1, and then I just solve using simple, later on I'll just elaborate. But in this case, I'm solving in terms of lambda is equals to 3. Okay, so I just sub in lambda is equals to 3, and therefore I have 3 minus 2 is equals to 1, and then the rest I just let it the same, and then 0, and 3 minus 1 is 2, minus 1, and then 4, minus 8, and 3 minus 3 is 0. And I would urge that please be very careful, because this may also be a careless mistake. So recheck your calculations, alright? Make sure it tallies. So what now I gotta do is to use reduced row echelon form, or maybe not, just some reduce rows method. Okay, or simply say simultaneous equation. So normally what I do is actually take the row 1 minus row 2, and one cheat code I will share with you now is to, when you're doing row systems, just write down a command over here like row 1 minus row 3, right? So when you do that, the next step, you know where it comes from. So for example, let me write down over here in a smaller matrix. Alright, 0, 2, minus 1. So I take the first row, I minus away the row 3. So no, what the hell am I doing? I take 4 row 1, okay, 4 row 1, because I want to play away this thing, I want to make it 0. Okay, if I assume that you know why I want to make it to 0 lah, because I want to see whether is this the same as this one. Okay, if this is the same, then I would know what I want to do next. Okay, so please be mindful about it. Okay, so I take 4 row 1 minus r3, so I times 4, simply I times 4 this thing, the row 1 over here. So 4, 8 and minus 8, minus 4 minus 8 and 0, the row 3, right? I would have 0, 8 minus 8 is actually 16, minus 8 minus 0 is minus 8. So I have 0, 16 and minus 8. And therefore you can see that this form is just a multiple of this form, right? If this whole thing multiply by 8, I will have this form totally. So this means that they are the same. With this concept, what I'm gonna do is straight away I would know that I will have a 2y minus z is equals to 0. Okay, this is the equation because they're actually the same, and they're equals to 0 because this is a homogeneous equation where we earlier ago we start off with it. Alright, and therefore 2y minus z is equals to 0. You may be tempted to write 2y is equals to z, and then you elaborate on that, stating that this is 2 1 and then some x value. Okay, please don't do this, you're gonna kill yourself. Alright, don't do this, this is the wrong method. Okay, what I would suggest is to set z is equals to some constant c. When that's the case, you will know that it's also, so when you do that, 2y is equals to z in this case. Okay, you also know that it's equals to c. So z is equals to c, 2y is equals to c, y is equals to half c. Alright, so you see the difference now. So since I know that my z is equals to c, y is equals to half, alright, I will simply say that c is just some constants. I will just say this is 1, alright? But because I just want to make things in terms of c, so that when you sub it in, so for example, I have, assuming that I have x value, because I haven't found my x value yet, so I just sub in x, and then I sub in my half c, because this is y, and then I sub in my z. So if I were to do this, then this is simply everything multiplied by c, right? C is just a constant. We just want to find its coefficient, that's all. I hope this makes you clear. So this step is very important. Set whatever coefficient that is, like, very simple, like just 1z or 1z, that's all, equals to c, and then you elaborate from there. Alright, 2y is equals to z. Please remember, this is a very important concept. People always make a lot of careless mistakes due to here. Okay, be very careful about that. And so once I know that my z is equals to 1 and my y is equals to half, now I can also solve for my x. Alright, so I just simply write down my x first. 2y minus 2z is equals to 0. So I'm simply rewriting this row 1 into here to find for my x, because I want to find for my equation. Right? So when I sub it in my y and z, since I already know my values, so 2 times half is actually 1, minus 2 times z is actually 2, right? It's equals to 0. So I have x, 1 minus 2 is minus 1 is equals to 0. So x is equals to 1. In this case, I can rewrite the situation as 1 half 1. Okay, so this is the one of my vectors. I would say eigenvectors. Okay, for 3 in this case. Alright, so this is my eigenvector, and this is simply the x that I found earlier. This is the z that I have determined earlier. Okay, should be this one, right? And then the half which is this one. So if you want to make it something that is nicer, because this is like half decimal, so you want to make it like whole number, so you just simply change it to 2, 1, 2. It's just a multiple of each other, that's all. So when you do this, then this is your eigenvector, and then this corresponds to this, and this sum out the type 3 of the system. Alright, and before I end, I have a little time, right? This type of solution, okay, this type of solution where you, sorry, hold on a while. Okay, never mind. So this type of solutions is when you have this type of equation, and then when you realize that two of the 3 rows are the same, so they are the same they are exact same. This means that there are many solutions. Alright, so there are many solutions. Then I'm going to come into this portion over here where we're going to talk about the parallel and the intersect unique solution and many solution type of things. So to reinforce on that, I think I'll just write it on the next video so that it can be a very formal form of interpretations of things. I shall see you there.